When drinking beer, there are many factors to consider. Principal among them are bitterness, the variety of flavors present in the beverage, along with their intensity, alcohol content, and color. Standards for those characteristics allow a more uniform determination to be made on the overall quality of any beer. Color, degrees Lovebond, or a degree L scale is a measure of the color of a substance, usually beer, whiskey, or sugar solutions. The determination of the degrees Lovebond takes place by comparing the color of the substance to a series of amber to brown glass slides, usually by a colorimeter. The scale was devised by Joseph Williams Lovebond. The standard reference method and European Brewery Convention methods have largely replaced it, with the SRM giving results approximately equal to the A degree L. The standard reference method or SRM is a system modern brewers use to measure color intensity, roughly darkness, of a beer or wort. The method involves the use of a spectrophotometer or photometer to measure the attenuation of light of a particular wavelength, 430 nanometers, as it passes through a sample contained in a cuvette located in the light path of the instrument. The EBC convention also measures beer and wort color, as well as quantifying turbidity in beer. Color based on standard reference method. Strength. The Plato scale is an empirically derived hydrometer scale to measure density of beer wort in terms of the extract's percentage by mass. It was developed in 1843 by Bohemian scientist Karl Balling as well as Simonac, and improved by German Fritz Plato. The scale expresses the density as the percentage of sucrose by mass, so a wort measured at 12 degree Plato has the same density as a water sucrose solution containing 12% sucrose by mass, denoted as 12% Brix. For the brewer, it has an advantage over specific gravity in that it expresses the measurement in terms of the amount of fermentable materials. Of course, as wort or must is composed of more solids than just sucrose, it is not exact. Degrees Plato are more popular in Central European brewing, and occasionally feature in beer names. The relationship between degrees Plato and specific gravity is not linear, but a good approximation is that 1 degree Plato equals 4 euro a brewer euro unregistered trademark S points a euro. Thus 12 degree Plato corresponds to an SG of 1.048, 1 plus, 12x 4x.001. Gravity refers to the specific gravity of the wort or must at various stages in the fermentation. This article focuses primarily on the brewing industry. The concepts and equations are basically the same in the wine-making industry. At various stages in alcohol fermentation, the density of the wort varies. Depending upon the depth that the hydrometer falls into the wort, the percentage of alcohol can be determined. Initially, the specific gravity of a wort is dependent mostly on the amount of sugar present and, therefore, specific gravity readings can be used to determine sugar content by the use of formulae or tables. This sugar content is expressed in units of grams of sugar per 100 grams of wort and called, in the brewing industry, degrees Plato, and in the wine industry degrees Brix. There is a difference between these units, but it is so insignificant that they may be used virtually interchangeably. Even when specified in terms of a degree P, it is correct and not uncommon to refer to the pre-fermentation reading as the original gravity, though it is more correctly termed the original extract. By considering the original sugar content, the brewer or vintner obtains an indication as to the probable ultimate alcoholic content of his product. The OE is often referred to as the size of the beer and is, in Germany, often printed on the label as Stammwar 1/4 LZE or sometimes just as a percent. In the Czech Republic, for example, people speak of 10-degree beers, 12-degree beers, and so on. As fermentation progresses, the yeast convert sugars to carbon dioxide, ethanol, more yeast, and flavor-producing compounds. The decline in the sugar content and the presence of ethanol both contribute to a lowering in the specific gravity of the wort, so that the formulae relating sugar content and specific gravity no longer apply. Nevertheless, by monitoring the decline in SG over time, the brewer obtains information about the health and progress of the fermentation and determines that it is complete when gravity stops declining. A gravity measurement taken at this time compared to the original gravity reading can be used to estimate the amount of sugar consumed and thus the amount of ethanol produced. Specific gravity is measured by a hydrometer, pycnometer, or oscillating U-tube electronic meter. Gravity measurements are used to determine the size of the beer, its alcoholic strength, and how much of the available sugar the yeast were able to consume. Alcohol by volume is a standard measure of how much alcohol is contained in an alcoholic beverage. The ABV standard is used worldwide. In some countries, alcohol by volume is referred to as degrees Gay-Lussac. XXX marks. The letter X is used on some beers, and was traditionally a mark of beer strength, with the more excess the greater the strength. Some sources suggest that the origin of the mark was in the breweries of medieval monasteries. Another plausible explanation is contained in a treatise entitled The Art of Brewing published in London in 1829. It says, "The duties on ale and beer, which were first imposed in 1643. At a certain period, in distinguishing between small beer and strong, all ale or beer, sold at or above 10 shillings per barrel, was reckoned to be strong and was, therefore, subjected to a higher duty. The cask which contained this strong beer was then first marked with an X signifying 10. And hence the present denominations of 20 and XXX on the casks and accounts of the strong ale brewers." In mid-19th century England, the use of X and other letters had evolved into a standardized grading system for the strength of beer. Today, it is used as a trademark by a number of brewers in the United Kingdom, the Commonwealth and the United States. Bitterness. Bitterness scales attempt to rate the perceived relative bitterness of beer. The bitterness of beer is provided by compounds such as isohumulones from hops used during brewing. The International Bittering Unit Scale, or simply IBU scale, is measured through the use of a spectrophotometer and solvent extraction. A calculation is performed on this absorbance to give a result in IBU. This technique was adopted at the same time as another method based on measuring the concentration of IAA isomerized I+ or minus acids in a beer, causing some confusion among small-scale brewers. The American Society of Brewing Chemists, in the introduction to its methods on measuring bitterness, points out some differences between the results of the two methods. While the results of the IAA methods are practically identical to those obtained by the IBU method for beer brewed with fresh hops, the IAAs of beer brewed with old or poorly stored hops, and with certain special hop extracts, can be significantly lower than the IBU figure. The European Bitterness Unit Scale, often abbreviated as EBU, is a bitterness scale in which lower values are generally less bitter, and higher values more bitter. The scale and method are defined by the European Brewery Convention, and the numerical value should be the same as of the International Bitterness Unit Scale, defined in cooperation with the American Society of Brewing Chemists. However, the exact process of determining EBU and IBU values differs slightly, which may in theory result with slightly smaller values for EBU than IBU. The bittering effect of hops is less noticeable in beers with a high quantity of malt, so a higher bitterness scale rating is needed in heavier beers to balance the flavor and achieve the same perceived bitterness as compared to a lighter beer. For example, an imperial stout may have an IBU of 50, but will taste less bitter than an English bitter with an IBU of 30, because the latter beer uses much less malt than the former. The technical limit for IBUs is around 100. Some have tried to surpass this number, but there is no real gauge after 100 IBUs when it comes to taste threshold. Light lagers without much bitterness will generally have 5 IBUs, while an India Pale Ale may have 100 IBUs or more. Automated combined systems. For high-throughput applications, automated systems are available. Simple systems work with adjustment data blocks for each kind of beer. High-end systems are matrix-independent and give correct results for example alcohol strength, extract content, pH, color, turbidity, CO2 and O2 without any product-specific calibration. Latest innovations are packaged beverage analyzers, that measure directly out of the package and give several parameters in one measuring cycle without any sample preparation. Oxidative degradation measurement. Oxidative deterioration of beer can be measured by the way of chemiluminescence or by electron spin resonance. Automated systems exist to determine the lag time of beer related to the antioxidant capacity to resist oxidative spoilage of flavors. Software tools are available to brewers to formulate and adapt recipes with a view to accurately measure the various values in brewing. Data can be exchanged in formats such as BeerXML to allow for accurate replication of recipes at remote sites or the adaptation of recipes to account for variations in locally available water, mash ingredients, hops etc. See also: beer style, information on the styles of beer, notes and references. External links, explanation from Brew Your Own, how to brew, hop bittering calculations, color measurement.